So in this video we're going to look at applying the inverse trigonometric functions that we've been developing over the last few videos, kind of in a computational fluency drill and grill kind of context, just to make sure we have a basic understanding. So this first example says find the value of sine inverse of negative root 3 over 2. So I'm going to establish a unit circle as my first step, probably a poorly drawn unit circle. So here's my circle of radius 1. And on the circle of radius 1, I want to think about where are the locations where I'll have a value of negative root 3 over 2 for my side ratio. The reference angle for it is going to be a 60 degree or pi over 3 angle in quadrant 1. So at the 60 degree mark, or pi over 3 radians, I have an ordered pair given by 1/2 and root 3 over 2. So this is at pi over 3 radians. And then there's two places on the unit circle where this side ratio negative root 3 over the side ratio root 3 over 2 is going to be negative. One I get if I reflect through the origin into quadrant 3. And here both the x and the y coordinate are negative. And the other one I can get by reflecting the 60 degree or pi over 3 radian over the x-axis down into quadrant 4. And here the x-coordinate would be positive and the y-coordinate would be negative root 3 over 2. So what we see is that there are two places on the unit circle where we get a side ratio, negative root 3 over 2. But what we want to remember is that the sine inverse can only give us an angle over a restricted domain, and that restricted domain is the interval from negative pi over 2 to pi over 2. So the sine inverse has to be the only angle on the interval from negative pi over 2 to pi over 2 that generates a side ratio negative root 3 over 2, and that angle is going to be a negative pi over 3 angle, bringing us to this ordered pair here, 1/2 negative root 3 over 2. So the angle that this outputs is going to be negative pi over 3 radians, or if we were in degrees, it would generate a negative 60 degree rotation to get to that side ratio. This next one says find the exact value of the cosine inverse of negative root 3 over 2. So again, I probably want to establish a unit circle, and on the unit circle I want to identify what is the reference angle in quadrant 1 that's associated with this side ratio, and it's going to be pi over 6 radians or 30 degrees. It's going to be my reference angle, so call them theta r. And the ordered pair there is root 3 over 2 comma 1/2. And I can generate two negative side ratios, negative root 3 over 2, one by reflecting over the y-axis into quadrant 2, where I get the ordered pair negative, let me write this better, negative root 3 over 2, positive 1/2, and the other I can get by reflecting down through the origin to here, where I get negative root 3 over 2, positive 1/2. And this angle right here, with the reference angle of pi over 6 radians, is going to be 5 pi over 6 radians. And this other angle is going to be the angle 7 pi over 6 radians. So the angle that gets me to this ordered pair is 7 pi over 6. But what we want to remember is that the cosine inverse was established by restricting the domain for theta on a cosine function to run from 0 to pi radians, or 0 to 180 degrees. So the range of the cosine inverse function has to be an angle on this interval, and that's going to correspond to 5 pi over 6, which is an angle between 0 and pi radians. So I'm going to identify that the cosine inverse of negative root 3 over 2 is going to simplify to the angle 5 pi over 6 radians. So this example, and this one gets at some subtleties that we have to be careful of. This says, hey, find the sine inverse of the sine of 5 pi over 6. So we're inputting an angle into the sine function. It's generating a side ratio. We're then evaluating that side ratio to get an angle. So we want to remember right away that the output to the sine inverse function has to be an angle between negative pi over 2 and pi over 2. The sine inverse function gives us an angle between those two. So right away what we see is the subtlety is that these aren't just going to cancel and give us 5 pi over 6, which is an angle that does not live in this interval. So we have to be careful. We can't just cancel because we're applying an inverse function. So probably the best thing to do is to draw out a unit circle, and you should do this over and over again until you can just see the unit circle in your head. So we're going to whip around here, and we want to go to 5 pi over 6 radians. 5 pi over 6 radians is going to be right here. Here's 5 pi over 6 radians. And it corresponds to a reference angle of pi over 6 radians. So we get the ordered pair here by looking at pi over 6 radians in quadrant 1, which corresponds to root 3 over 2 comma 1/2, and then reflecting that over to the side. So the ordered pair right here is the ordered pair negative root 3 over 2 comma 1/2. So when we're working this through, what we're going to get is sine inverse of the sine of 5 pi over 6. And the sine of 5 pi over 6 is going to be the y coordinate on the unit circle. So this is going to simplify to sine inverse of 1/2. So the sine inverse of 1/2 wants to generate an angle on the interval from negative pi over 2 to pi over 2 that has a side ratio of 1/2. And we look over here and we see that between negative pi over 2 and pi over 2, the angle pi over 6 generates a side ratio of positive 1/2. So the output to sine inverse of 1/2 is going to be the angle pi over 6 radians, or if we're in degree world, 30 degrees. So this example is here to demonstrate that you can't just cancel when you're working with inverse functions. You have to pay attention to the domain and range of your inverse function. This example says find the arc sine of the cosine of 2 pi over 3. So again, let's establish a unit circle, even if it's poorly drawn. 2 pi over 3 radians is going to be up in this position. This is 2 pi over 3 radians. Its reference angle is pi over 3 radians, which corresponds to this angle in quadrant 1, pi over 3, or 60 degrees. So the ordered pair here is 1/2 and root 3 over 2. When we reflect over into quadrant 2 to get our 2 pi over 3 angle, we're going to have the ordered pair negative 1/2 root 3 over 2, square root of 3 over 2. And what we're going to see then is that when we do the arc sine of the cosine of 2 pi over 3, the cosine of 2 pi over 3 is going to be the x coordinate on the unit circle. So it's going to simplify to arc sine of negative 1/2. And for the arc sine of negative 1/2, because the arc sine is going to give us an angle, theta, that has to be on the interval from negative pi over 2 to pi over 2, we're after a side ratio of negative 1/2 that is generated by an angle in this interval. So just quickly scratching in a second unit circle, just because my first one's a bit busy, what I want to identify is that a side ratio of positive 1/2 is generated by a pi over 6 or 30 degree angle, where we have root 3 over 2 comma 1/2. This is a 30 degree angle here, or pi over 6 radians. So to get the negative 1/2, I need to reflect this point down into quadrant 4, which is going to give me root 3 over 2 comma negative 1/2. The y-coordinate will be negative, and this angle will be a negative pi over 6 rotation into quadrant 4, generating the side ratio negative 1/2. So I'm going to get negative pi over 6 radians, which is an angle on the interval from negative pi over 2 to pi over 2. So last example. So this one we need to construct a triangle that reflects the statement that we see. So what we want to identify is we have an input into the sine inverse function. And we know that the sine function, we input angles and the output is a side ratio. In fact, it's the y-coordinate over the radius on the circle. So when we have the inverse function, sine inverse, the input is going to be a y-coordinate over the radius, and the output is going to be an angle. And what we want to do is construct this angle by recognizing that we're putting a side ratio into the sine function. If it's y over r going into the sine function, I look up here. Well, what's getting put into the sine function up here? X over the square root of 12 plus x squared. So I'm going to let this correspond to my y and my r, or I can think of it as, the other way I can think about it is sine has also been defined as opposite over adjacent, might be another way to think about it. So this is going to be the side opposite my angle. Opposite over adjacent, that's horrible. Opposite over hypotenuse. And this is going to be the hypotenuse of my right triangle. So what I'm going to do is construct a right triangle. And then I'm going to make this angle. The sine inverse wants to output an angle. I'm going to construct this angle. I'm going to say, hey, I am the angle theta. And then what do we know? We know a side ratio is going into the sine inverse function. And I know that this numerator has to be the side opposite that angle. And the denominator has to be the length of the hypotenuse or the radius of the circle. So I'm going to get 12 plus x squared sitting here. And what I want to do, because I need to calculate the cosine, I'm going to need to know the length of the side adjacent. So I'm going to call it A for adjacent. And then I'm just going to use the Pythagorean theorem to calculate this, or recognize that the square root of 12 is going to be this length. But if we don't recognize that, we can just say, hey, I'm going to use the Pythagorean theorem. I'm going to say A squared plus x squared. The sum of the squares of the legs of the right triangle will be equal to the square of the hypotenuse, 12 plus x squared, squared. And when we square the square root, we're going to get the 12 plus x squared coming out of that. I subtract the x squared from both sides. I get a squared equals 12. I'm going to take the square root of both sides. I'm going to use the positive square root. And then I'm going to write the square root in simplified radical form by recognizing 12 is 4 times 3, which can be simplified to the square root of 4 is 2, and the square root of 3 is the square root of 3. So I can label this side on the triangle as 2 square root of 3. Once I do that, I'm ready to evaluate the expression. I start off with the cosine of the sine inverse of a side ratio x over square root of 12 plus x squared. But when I calculate the sine inverse, the output is an angle, but I constructed the angle that goes with this side ratio. So this is going to simplify to the cosine of theta. I constructed theta to match this side ratio. And then I can say, how do I calculate the cosine of theta? Well, I take the side adjacent, which is 2 square root of 3, and I divide it by the length of the hypotenuse, which is the square root of 12 plus x squared.